In this video, we'll be talking about rate law, which is the mathematical relationship of reaction rate with the reactant concentrations. So when A plus B forms a product, the rate would be K times the concentration of A to the power of X and the concentration of B to the power of Y. So X and Y are the reaction orders, which are determined by experiment data, and K is the rate constant or the proportionality factor, and the unit and value of K differs for every reaction. So the rate will usually have a unit of molarity over time. Okay, so let's try solving the first question. We will solve for the reaction orders first. So X represents the impact A has on the rate, and Y represents the impact B has on the rate. First, we'll be solving for X. So you have to look for two of the three experiment data in which the concentration of A changes, but the concentration of B remains constant. And in this case, it would be experiment 2 and 3. So you can see that when the concentration of A doubles, the rate remains the same, and this basically means that the reaction order is 0 because 1/2 to the 0 power would equal to 1. So in conclusion, the concentration of A has a reaction order of 0. So now we'll be solving for Y, and you have to look for two experiment data in which the concentration of A is constant, but the concentration of B changes. So in this case, the concentration of B halved, and you can see that the rate decreased by a factor of 4. So then that basically means 2 to the power of Y equals 4, meaning that Y is equal to 2, and therefore the concentration of B has a reaction order of 2. So now the final step is to solve for the rate constant K, and in order to do so, you have to plug in the values for the rate and the concentration of B from any of the three experiments in the data table, and it doesn't matter which one you use as long as all the values are from the same experiment. So in this case, I'll just use the value from experiment 2, which is highlighted. And so the rate is K times the concentration of B squared. And to solve for K, you know that it's this. And plugging in the values from experiment number 2, the answer is that K equals 0.0027. And be sure to write the units because the units are different on K every time. So make sure that there are two parts to your answer, which is the rate law equation and the rate constant K.